Numbers are letters? Letters are numbers? Variables? Equations? X equals negative b plus or minus the square root of b squared minus 4ac over 2a? Hi, I'm Dr. Erica Brzozowski. This is Study Hall, and here are 9 things you should know so you won't feel like the least common denominator in algebra class. Let's start simple. What even is algebra? Algebra is a type of math, like geometry or trigonometry or calculus. But while geometry deals with shapes, and trig deals with triangles, and calculus deals with whatever that is, algebra is a branch of math that deals with the relationships between changing things. And if you think that sounds vague, you're right. Algebra is shrouded in mystery. That's because algebra is really more than just a branch of mathematics. It's like one of the fundamental branches of mathematics. And on that branch, there are lots of little twigs. Like there's linear algebra, which deals with organizing information into lines and planes and looking at how those relate. It's used in everything from other math fields like geometry to computer programming and machine learning. And more importantly, it's my personal favorite kind. There's also abstract algebra, which uses a lot of those same ideas and rules to study other mathematical structures and shapes. Like the patterns we see in different crystal structures are very abstract algebra. So is chemistry just math? We're not saying no. But in your first algebra class, you'll start with elementary algebra, your first step into the unknown. Elementary algebra introduces us to the properties of familiar math structures, like the numbers we all know and love. So where did algebra come from in the first place? Well, people have been doing algebraic things for a long time, using variables and equations, which we'll talk about in a minute, to solve complex mathematical problems. As early as around 2000 BCE, the ancient Egyptians and Mesopotamians were using algebraic concepts, including linear and even quadratic equations. In ancient Greek, Indian, and Chinese mathematicians all built on these concepts too, usually for the sake of solving complex geometric or monetary problems. But the field of algebra as we know it today is usually credited to this guy, Muhammad ibn Musa al-Khwārizmī. Al-Khwārizmī was a Persian mathematician living around the 9th century CE. Apart from being an accomplished geographer and astronomer and kind of inventing numbers, he's usually credited as the father of algebra. That's because he was the first guy to teach algebra for algebra's sake, rather than as part of geometry or some other discipline. But algebra wasn't called algebra back then. It was just a type of math that didn't really have a name. Until around 820 CE, when al-Khwārizmī wrote a book about it. The book was called Algebra, which in Arabic means completion. Thus, algebra was born. In Algebra, al-Khwārizmī taught all kinds of things, like how to solve linear and quadratic equations, how to calculate the area and volume of different shapes, and how to navigate some very mathematical Islamic inheritance laws. But it also taught elementary algebra, the kind of thing you'll learn in your first algebra class. At that level, algebra is basically about using numbers, variables, and operations to solve equations and functions. It relies on that principle of completion, or making things work out perfectly, to figure out how these things relate to each other. So let's go through them. You probably already know what numbers are, so you can check that one off the list. But what are variables? The word variable can mean lots of different things depending on how you use it and what discipline you're talking about. But in algebra, a variable is usually x, or sometimes y or z. Or if we're getting really fancy, maybe you'll throw a Greek letter in there. Basically, it varies. But whatever letter or symbol we use, variables stand in for unknown quantities, or values that we know are there, we just don't know what they are yet. Like, say I make a flat rate of $100 a day hosting community circles at Algebraics Anonymous. If you asked me how much I made today, listening to mathematicians wax poetic over harmonic sequences and nilpotent matrices, I would say that my total pay is equal to $100. But what if I also make tips for my grateful clients? Then my daily pay is $100 plus however much I make in tips. But that amount isn't always the same. It varies every day. So I can't give it an exact value. I just have to say that my pay is $100 plus tips. But I don't need that whole word. I can just write that my pay equals $100 plus T, where T is the amount of tips I get that day. And I don't need the word pay either. That's another quantity that can change depending on the day. So I can replace it with a variable too, maybe P for pay. In algebra class, we'll see a lot of X when talking about variables. But unless they're counting up their xylophone stores all the time, why are people always using X in algebra? Well, one answer is that they just kinda do. In English, X is conventionally used as a symbol of the unknown. Think about Malcolm X, who chose his last name in honor of his unknown African ancestors, or how X marks a spot on a pirate treasure map, or the unknown, inscrutable website formerly known as Twitter. But there actually is a theory about why we use X so much in algebra specifically. And just like algebra itself, it goes all the way back to Mr. al-Khwārizmī. The theory goes that after its big debut, more and more people started writing about algebra. And since al-Khwārizmī wrote in Arabic, most of these early writings were in Arabic too. They talked about unknown variable quantities with the Arabic term al-Shalan, which means unknown thing. Some people think that later, when Spanish scholars tried to translate this work, they ran into a problem because the sh sound doesn't exist in Spanish. So they tended to replace it with the k sound, which in the Greek alphabet is written with the letter chi, which looks a lot like X. A different theory credits X to the French mathematician René Descartes. In his geometry work in the early 1600s, Descartes advocated for the use of the last letters of the alphabet, X, Y, and Z, to represent variable quantities. We don't really know why he did that though. Maybe he got the idea from al-Shalan. Or some people think that maybe he just had a lot of extra X's for his printer lying around and needed something to do with them. Wherever X came from, it joined the algebra club and got super popular, just like you will when you drop all the algebra knowledge you got from watching this video. But that doesn't mean we can't use other variables like t for tips to mark our unknown quantities. X is the standard, more or less, but sometimes you just gotta throw a Q in there, or even a J. But the moral here is that variables let us use variable numbers in our math, which basically lets us do math on the unknown. Once we've got a variable, even though we don't know what its value actually is, we can manipulate it using operations. In algebra, operations are just things you do to numbers or variables. The basic ones are addition, subtraction, multiplication, and division. There's also exponentiation, which is a fancy kind of multiplication, and finding roots, which is the reverse of exponentiation. So if my pay equals $100 plus t for tips, the operation is addition. Operations are a key tool we use in creating mathematical phrases, or expressions. Expressions are basically just statements made up of numbers, variables, and operations. Like 2 times 2 is an expression, or x over y, or $100 plus t. We're taking some kind of situation and writing, or expressing, it in math, like adding my tips onto my flat rate pay. And then we can build on expressions to create the crown jewel of algebra, the equation. An equation is a statement of equality, saying that one thing is equal to something else. We can build equations by putting terms, numbers or variables, or expressions on either side of an equal sign. So 5 equals 5, that's an equation. 2 plus 3 equals 5, that's an equation too. We could also write 2 plus 3 equals 1 plus 4, or 1 plus 4 equals 7 minus 2. Those are all equations because we're saying that those two numbers or expressions are equal. $100 plus t equals p. That's an equation too. And it's the kind you'll run into most often in algebra because it contains variables. Sometimes we can even solve equations to find the value of a variable. Like after a long day of reciting the mathematician's prayer, grant me the serenity to accept the equations I cannot solve, the courage to solve the ones I can't, and the wisdom to know the difference. I took home a grand total of $125. So how much did I make in tips? Now that we know the value of my pay, we can replace p with its actual value, $125. So now we have $100 plus t equals $125. Now we can solve for t or figure out what value of t makes the equation true. Like if I say t is $0, that doesn't work because 100 plus 0 is still just 100. So in this case, t has to be 25 because 100 plus 25 equals 125. As I learn at Algebraics Anonymous every day in excruciating detail, not all equations are that easy. But the basic idea is the same. Solving an equation means finding the unknown value that makes a mathematical statement true. Setting up equations like this is useful because it lets me see how my pay, my tips, and my flat rate are all related to each other. If I don't already know how much I earned in a given day, though, I can't solve the equation to figure out how much I got in tips. But I can still show the relationship between my tips and my pay using something called a function. In algebra, a function is the version of the math sentence that accounts for all the possible values that could make the equation true. And it works a little bit like a machine. A function takes an input, a certain specific number, and performs operations on it to create an output, another certain specific number. And when they're written out, functions can look a lot like equations, and that's because sometimes they sort of are. Like we could have a function that says my pay, p equals $100 plus tips. That's an equation, because we've got two things that equal each other. But it's also a function because it can take an input, say the amount of tips I make, and use it to create an output, my total daily pay. And instead of having just one answer where P is $125, so T has to be $25, there's a whole set of values that work for this function. Like if my tips one day are $10, my pay will be $110. If T is $50, P will be $150. If Elon Musk shows up at Algebraic Anonymous and tips me $1 million, P will be $1,100,000. And he's still not off the hook for the X business. $1 million is nice, but having a moral compass is nicer. We can show a function in a couple different ways. We can leave it as our equation, P equals $100 plus tips. Or we could write it in function notation, which looks like this. And this is basically saying that the function, f, manipulates the variable t through this operation. We could also show it on a graph, with tips on the x-axis and pay on the y-axis. This way we can visualize all the possible pairs of t's and p's that work as solutions. Functions show us the relationship between two variables, and being able to solve and graph functions is a big deal, not just in algebra, but also in other math like trigonometry and calculus. So once you build them up, your algebra skills can serve you in all kinds of mathematical situations. You can know all the possible unknowns. But what with all the nervous wrecks in Algebraic Anonymous, maybe you don't want to be in any more mathematical situations. Or maybe you're into all of that. No judgment here, me too. But if you don't want to keep studying math, is it still worth it to study algebra? Mathematically speaking, yes. See, everybody ends up in mathematical situations whether they like it or not. And there are tons of everyday problems you can solve with algebra. Calculating a discount price, having a recipe, figuring out how many tips you need from your mathematical support group in order to pay the rent. All of those things involve solving for unknown quantities, which is exactly what algebra teaches us to do. And even though we have smartphones to do the arithmetic for us, understanding algebra helps us know how to plug in the numbers to find the answers we really want. But okay, even though budgeting and recipe having are important, they're still kind of boring. But there's another really exciting reason to study algebra. It might open up whole new parts of your brain. Algebra is usually a person's first foray into higher level math beyond basic arithmetic. Learning any kind of math helps build logic, reasoning, and problem-solving skills that can help you in all kinds of areas. But algebra teaches you to use numbers in a more abstract way, which opens the doors for a specific set of algebraic thinking skills, like recognizing patterns, making generalizations, and understanding change in a mathematical way. Those skills can help you feel a lot more comfortable and confident with numbers in any context, from shopping, to sports, to computer programming, to the very niche grievances mathematicians bring to your very niche support group. So whatever you want to use it for, learning algebra can give you new ways to solve problems, and maybe even turn you into the mathematician you never thought you'd be. There's so much to learn about algebra, and 9 questions only scratch the surface. But hopefully, these answers make you feel a little more confident. And if not, there's always Algebraic Anonymous. If you're interested in taking an online, real-world college math course for just $25 and unlocking the chance to earn college credits from ASU, check out GoStudyHall.com or click on the button to learn more. And if you want to help us out, give this video a like, comment your favorite number, and smash that subscribe button. Thanks for watching. See you next time.